Hello everyone, welcome to my channel. This is Sir Gabs. If you are new here, just hit subscribe and click on the notification bell for future videos. In this video guys, we will be talking about word problems involving circles. Now before we start guys, let's try to recall some things. First, we have the distance between 2 points. That is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity of y sub 2 minus y sub 1 squared. We also have the distance from a point to a line. So when we say a point to a line, I have an illustration here. There's a given point and there's a given line. The distance between them must be the shortest distance from the given point to a given line. So that should be this one. Now, how do we know that that is the shortest distance? Okay, so the shortest distance, guys, will always form a 90-degree angle with a given line. Again, the line segment is the shortest distance if and only if the line segment is forming a 90-degree angle to the given line. Now, if the given point is the center of the circle, okay, so I have there the x sub c and y sub c. That means the x coordinate of the center of the circle and the y coordinate of the center of the circle. Then the distance formula becomes the absolute value of ax sub c plus by sub c plus c all over the square root of a squared plus the b squared. Okay, so x sub c here is the x coordinate of the center and y sub c is the y coordinate of the center. Okay, so the full illustration looks like this. There's a circle and there is the center here. The distance from the point to the given line is also the radius of the circle. Okay, so again, the distance from a given point to a given line this time is also the radius of the circle. And the given line also becomes the tangent line. Because notice that the line is intersecting the circle at exactly 1 point. So, the line given is now considered a tangent line. The point of intersection between the circle and the tangent line is known as the point of tangency. Okay? Now, the area of the circle, as you may recall, okay, so that should be A equals the pi r squared. So when we say area, it is the total space covered by the circumference of the circle. If you may recall also the circumference of the circle, that is equivalent to the 2 pi r. So the difference is if we are talking about the area, we are trying to measure the space covered by the circumference. Okay, so this one is the circumference. The length of this circumference is computed by 2 pi r. So again, I have illustrated already what is circumference in the previous video. You may consider watching the video again to recall what is circumference. Then we also have the standard equation of a circle. If you may recall, that should be the quantity x minus h squared plus the quantity of y minus k squared equals r squared. We will also use here the general equation of conic sections. Again, the general equation of conic sections is in the form of ax squared plus the cy squared plus dx plus ey plus f equals 0. Now, since we are talking about conic sections and specifically about a circle this time, it should be considered that A and C are equal. Okay, so in this discussion, I am only considering general equations of conic sections where A and C are equal. Because for the general equation to be an equation of a circle, A and C, so this one, the numerical coefficient of x squared and the numerical coefficient of y squared must be equal so that the equation is a circle. Now, let's proceed. We have here word problem number 1. Find the equation of the circle whose center is at 4, 3, while its circumference is passing through 2 and negative 5. Now, the best thing that you will do first is to illustrate the situation. Because if you cannot really, or let's say if you are not yet matured in solving problems, the best practice is to illustrate first the situation. So we have here, let's have the x-axis and the y-axis. Of course, since this is just an illustration, you don't need to be you don't need to be really very specific with the points, with the labels. Okay, so I'm just drawing like here across. So we have the x coordinate, I mean the x-axis and the y-axis, the vertical and the horizontal. Of course, let's assume this point is 4 and 3, which is the center. So why am I putting the point here? I'm putting the point here because 4 and 3, as you know, is in quadrant 1. But I am not really trying to be correct or trying to be accurate with if this is 4 or this is 3, as long as it's somewhere in there, and I assume that this is 4, 3. Because again, this is just an illustration. Now let's talk about 2 and negative 5. So 2 and negative 5 is in quadrant 4. So maybe somewhere here. Maybe somewhere here is 2 and then negative 5 is here. Okay? Next, consider the circle as this one. This one is the whole circle. Why? Because this is the center, and then it says there that the circumference is passing through 2 and negative 5. So this is circumference, as you know, which means it passes through 2 and negative 5. Now, you might have realized this one already, that the distance from the center, 4, 3, going to this point 2, negative 5, is considered the radius of the circle. Right? Because if you may remember the definition of a radius, that should be the distance from the center of the circle to any point on the circumference. Actually, if you are already matured in solving word problems, you can just skip the illustration. You can just actually imagine that if this is the center and this is point on the circumference, then the distance between them must be radius. But if you think this is quite hard for you, you may consider trying to illustrate first, see the picture, plan, and then solve. Okay, so we have here the center 4, 3, 2, negative 5 as the point of the circumference. We will now solve for the radius, because if you will actually recall also the standard form of equation, I am trying here to use SF or the standard form. This is x minus h quantity squared plus y minus k quantity squared equals r squared. For us to get the equation, you must have h, k, and r. Okay, again, you must have h, k, and r. So substitute the value of h, substitute the value of k, and substitute the value of r, and then do algebra, and then you will get the general equation. Because here in the problem, it says find the equation. It is not being specific if standard equation or general equation. If that's the case, always consider the general equation. Now, as you can see, h is already 4 because h is just the x coordinate of the center. So that's easy. K is equal to 3. 3 or k is just the y coordinate of the center. So okay. Now for r, this is the problem because we don't have the value of r. And in order for us to get the value of r, we must recall the distance formula. Why? Because again, we have realized a while ago that the radius is just the distance from the center 4, 3 to the point on the circumference 2, negative 5. So we will now get the distance between the 2 points using the formula again that we tried to recall a while ago. So square root of this one. Now substitute. Of course, your x sub 2 is this one, the second value of x. And then your x sub 1 is the first value of x, which is 4. So you have 2 minus 4. Then you have y sub 2 is negative 5. And then your y sub 1 is 3. So you have negative 5 minus 3. Simplifying further, you have r equals the square root of 4. Because, right, you have negative 2 here squared is positive 4. You have negative 5 minus 3, that's negative 8. Quantity squared, so you have actually 64. And then summing them up, you have actually square root of 68. If you will try to simplify, that should be 2 square root of 17. Now we have completed all three requirements, h, k, and r. From here, you can now use the standard form of equation. Okay, again, you can now use the standard form of equation to obtain the general form of equation. Always remember that if you are trying to get the general form of equation, you must have the standard form of equation first, and then try to do the algebra, then obtain the general equation. So just substitute the values by then. You have here x minus 4, h is 4 again, so you have substituted. Then k is 3, so substitute again. And then r is this one, 2 square root of 17, and then take the square. Next, you will now come up with, okay, special products. You may recall if you have forgotten it, so you just review. No, we have actually provided you review about algebra, so just try to review it. So in here you have x squared, and then you have x times 4, that's 4x times 2, that should be 8x, that's a negative sign. So negative 4 squared, that should be positive 16. On the other side, you have here y squared, then y times negative 3 is negative 3y, times 2 you have negative 6y. Negative 3 times negative 3, this should be positive 9. And then here, you can actually have 4 and then 17. So 4 times 17 is equal to 68. Or if you want, instead of using 2 square root of 17, you can just actually substitute square root of 68. Anyway, they're just equal, right? And then the square root of 68, taking the square, you can just cancel the radical and this 2 here. So you have actually 68 left. From here, you can just arrange now. So first, you have to write x squared, then followed by y squared, then the negative 8x, then the negative 6y, then add all constants. So you have positive 16 plus 9, and then you do the additive inverse here. So you subtract 68 to make it 0, so you also subtract 68 on the other side. In the Philippines, guys, now here we know this as transposing, but the correct term for that is additive inverse. So we are trying to add the inverse of the number. So from 68 here, to make this 0, I have to subtract 68, right? And then the property of equality, since I subtracted 68 here on the right side, I must also subtract 68 on the left side. So that's why I have minus 68 here. But anyway, if you're comfortable with the term transposing, then just do it. So from here, you will now come up with x squared plus y squared minus the 8x minus 6y minus 43 equals 0. So always remember, if you're solving a word problem, your final answer must be in complete sentence. So therefore, the equation of the circle described in the problem is x squared plus y squared minus 8x minus 6y minus 43 equals 0. Guys, you may check this equation. Okay, how do you check if your answer is correct? Just check this one in your Desmos app or in your GeoGebra, whatever app are you using. So graph this one, this equation, and then try also to consider the center and this point if it matches. So try to see the figure if this is really the center of the circle and if this point is really passing through the circumference of this circle. Okay, so that's for word problem number 1. Let's proceed to word problem number 2. For word problem number 2, guys, so we have actually a different situation. So we have a given line x plus 2y minus 4 equals 0 is tangent to a circle whose center is at negative 1 and negative 3. Now our goal is to solve for the radius of the circle and solve for its general equation. First, I always suggest to illustrate the situation. We have the horizontal and vertical lines. Then we actually have the intercepts. So the easiest way to draw the line is to use intercepts. Okay, so when you solve for the x-intercept, just assume y equals 0. And then if you solve for the x-intercept, just assume y equals 0. So you may use or you may try to watch some videos about the review in intercepts to recall how to do it. Now, from here, you can also plot the center of the circle, negative 1 and negative 3. Remember, it also says that, or the problem is saying, that the line is tangent to the circle. So this line is actually a tangent line. And this one is the center of the circle, so meaning, this is the circle, and this one is the point of intersection. Okay? So from here, you can actually say that this point of intersection is known as the point of tangency. And if you will try to connect the center of the circle to the point of tangency, it will always form a 90-degree angle to the tangent line. Okay? Or the line segment from the center of the circle to the point of tangency is always perpendicular to the tangent line. So, from here, we can already conclude that that line segment is the distance. Okay? I mean, is the shortest distance. Now, if that is a shortest distance, remember the formula, right? So in the preparation, I actually told you or actually showed to you the shortest distance from a point to a line. Because notice that if this is the center, a center is always a point, and this one is a line. And since this is forming a 90-degree angle, then we are just like solving for the distance from a point to a given line. And notice that that distance is actually the radius of the circle, right? Because this one is a center and this one is a point of tangency, which is also a point on the circumference of the circle. So getting the distance between them is just like getting the radius of the circle. Okay? So to solve for the radius of the circle, all we have to do is to solve for the distance from that point, the center, to the given line, which is the tangent line. Okay? So you must have realized that r is the distance, or the radius is the distance from -1, -3 to line x plus 2y minus 4 equals 0, which is the tangent line. So from here, just recall, distance is equal to the absolute value of ax sub c plus by sub c plus c all over the square root of a squared plus the b squared. Then look for the values. Of course, now if you may recall, a, that is the numerical coefficient of x. So this should be 1 here. So that's a equals 1, b equals positive 2, and c is equal to this one, the negative 4. Then you have x sub c is negative 1. So x sub c, as I said, is the x coordinate of the center of the circle. So that's negative 1. Then y sub c is negative 3. So this one. Then all you have to do is to substitute all these values to the formula. So you will now have the absolute value of 1 times negative 1 plus 2 times negative 3 plus the negative 4 all over the square root of 1 squared plus the 2 squared. So from here, you will come up with the absolute value of negative 11 all over the square root of 5. So you may use a calculator to be more accurate, okay, to be more so sure in your answers. Then, of course, using the absolute value concept, you will come up with the positive 11 all over the square root of 5. If you may be asking, why do we consider or why do we take the square root? It's because there's no such thing as a negative distance. It's always positive. So that's why we take the absolute value. So from here, rationalizing, we have to consider 11 square root of 5 all over 5 as the distance, okay? Again, d is 11 square root of 5 all over 5. But in the same way, guys, you also have, okay, you also need to see it. You need to see it as the radius of the circle as well. Okay? So distance is also the radius of the circle. So whatever is the distance is also the radius of the circle, which is 11 square root of 5 all over 5. So the first goal is already completed. Now we have the second goal, which is to find the general form of equation. Again, remember in the previous example, I said for you to get the general equation, you must have, okay, you must have the standard equation first. So the standard equation, you need what? You need h, k, and r. So the same as the previous example. H is negative 1, right? The negative 1, I mean the x coordinate of the center is negative 1. Then k is negative 3, the y coordinate. Then r, we already have it. You have 11 square root of 5 all over 5. So from here, just do algebra. So substitute to the standard form of equation. So you have x plus 1 because you have minus and negative 1. So double negation, it becomes plus 1. Then you have y minus negative 3. So basically you have plus 3 because again, that's a double negation. Then substitute the value of r, which is this one. So you will come up with the quantity 11 square root of 5 all over 5 and then square. Then special products, apply special products. In some laws of exponents, you have now x squared or x times x, and then you have x squared. X times 1 is x times 2, you have 2x, and then 1 times 1 is 1. Plus y times y is y squared. Y times 3 is 3y, you have times 2, so you have 6y of course, and then 3 times 3 is equal to 9. Okay, then you have the square of this value is equal to 121 times 5 all over 25. So how did I do it? That is just simply 11 squared is 121. Then square root of 5 squared is, of course, cancel the radical sign or radical symbol. So you have positive 5. Then 5 squared is just equal to 25. Okay, so actually you can just do it right away using our calculator, but I'm just showing here the step-by-step process in solving this value. Then from here, I can just actually simplify 5 and 25, right? Because that's actually 1 over 5. So cancel 5, we have 5 left here. Then I also arrange the left side, so that should be x squared first and then y squared. You have 2x plus 6y plus 1 plus 9, following the format of general equation. Then in writing the general equation, guys, there must be no fraction form. So for me to get rid of this 5 here, I will multiply the whole equation by 5. Okay, again, to remove this 5 here in the denominator, because again, I need not to have fractions in my general form. Okay? So I will get rid of 5 by multiplying the whole equation by 5. So am I violating any rules in algebra or in math? No, I am not violating anything because I am maintaining the equality of the equation. So it is still equal as long as what I am doing on the left must be done also at the right. So I will be multiplying this by 5 or the whole thing by 5. So I will come up with 5x squared plus 5y squared plus 10x plus 30y plus 5 plus 45, and then this becomes 121. So I cancel 5 here because of course if I multiply this by 5, 5 over 5 becomes 1. 121 times 1 is just simply 121. Then just arrange now. So you have 5x squared plus 5y squared plus 10x plus 30y plus 5 plus 45. Additive inverse, I should make this 0. So subtract 121. Okay? So again, equality or property of equality, I should also subtract 121 on the left side. So that's why I have here minus 121. Then combine these constant terms here, 545 and negative 121, you will come up with negative 71. So just copy all these other terms. Then this one is equivalent to negative 71. Okay, so the final answer is this one. You have therefore the radius of the circle described in the problem is this one. 11 square root of 5 all over 5. Do not forget to write units. While the general form of equation of the circle is this one, which is 5x squared plus 5y squared plus 10x plus 30y minus 71 equals 0. Actually, I have two problems left. I have two sample problems left, and I will be explaining those two word problems in my next video, in a separate video rather. Okay, so thank you for watching this video and see you in the next video anyway. Thank you.